recording for 7.1 worksheet. Let's see if I can get this working here. Okay, so 7.1 worksheet. I am gone, so I thought you can maybe watch this video if you're stuck on one of the problems to help you through it. So the first problem on 7.1 worksheet, the stipulation is the sine of theta is equal to 2 over 5. You are in the first quadrant looking at the stipulation, and you are trying to find the cosecant. Well, you look on your formula sheet, and sine is the same thing as, so you're trying to find cosecant of theta. So you're going to do sine is the same thing as 1 over cosecant. So I switch the sine to 1 over cosecant from the formula, and that's equal to 2/5. You have to show all your work, even though that you know that those two are reciprocals of each other. You have a fraction equals a fraction. You cross multiply, so you have 2 cosecant of theta equals 5. So cosecant of theta is equal to 5/2. The reason why you have to show formulas is because in 7.2 it's all driven, formula driven, and you have to know how to do it, not just know that they're reciprocals of each other. Okay, the next problem, number 2. The sine of theta is equal to 1/4. The stipulation puts you in the first quadrant because it's 0 to 90, and we're supposed to find the cosine of theta. Okay, so if you look at your reciprocal identities, there are 6 of them, and none of them are associated with the sine and the cosine. But if you look down at the bottom, called the Pythagorean Identities, I'm going to use the sine squared theta plus cosine squared theta equals 1 to help us do this. And we know that the sine of theta is equal to 1/4, so you're going to take the 1/4 and you're going to square it, plus the cosine squared theta equals 1. 1 times 1 is 1, and 4 times 4 is 16, plus the cosine squared theta equals 1. So cosine squared theta is equal to 1 minus 1/16, because I brought the 1/16 over. 1 is the same thing as 16/16, which makes the cosine squared theta is equal to 15/16. But we're trying to find the cosine. So you need to do the plus or minus, you need to square root both sides. So you need to do the plus or minus the square root of 15 over the square root of 16, which is 4. But you are in the first quadrant, and cosine is positive in the first quadrant. So the answer is the square root of 15 over 4. Okay, the next problem. Another thing, if I'm going too fast, you can always stop the video and re-watch it. I have another video that I need to do, so I was just trying to go a little bit faster so I can get the 7.2 video in also. So you have the cosecant of theta is equal to the square root of 11 over 3 for the third problem. And you are in the second quadrant. That's really important for the sines. And we're trying to find the cotangent of theta. So again, if you look at your reciprocal identities, there are none associated cosecant and cotangent. But down below, you can do 1 plus cotangent squared theta equals cosecant squared theta. And where did I find that? Down at the bottom left-hand corner of your formula sheet is the Pythagorean Identities. And I'm going to leave cotangent squared theta over here, and I'm going to bring the 1 over to join the cosecant side by subtracting. So cotangent squared theta, and we already know that cosecant of theta is the square root of 11 over 3, so you're going to take the square root of 11 over 3 and square it minus 1. So cotangent squared theta is equal to the square root of 11 times the square root of 11 is 11, and 3 times 3 is 9, minus, and I'm going to change the 1 to 9 over 9, which gives you cotangent squared theta is equal to 2/9, because 11/9 take away 9/9 is 2/9. square root, you're going to get cotangent of theta is equal to the square root of 2 over the square root of 9. I can break that up. And the square root of 9 is equal to the square root of 2. The square root of 9 is 3. And cotangent is negative in the second quadrant. So the answer is a negative root 2 over 3. And then the last problem on the front page is number 4. The sine of theta is equal to a negative 1/3. This one puts you in the third quadrant, and you're trying to find tangent. And tangent is positive in the third quadrant. Okay, so what I'm going to do is they give you the sine of theta. So I'm going to do the sine squared theta plus cosine squared theta equals 1 by the Pythagorean identity. I'm going to replace the sine of theta with the negative 1/3, but I have to also square it, plus the cosine squared theta equals 1. Anything squared in math is going to be a positive, so a negative 1 times a negative 1 is 1, and 3 times 3 is 9, plus the cosine squared theta is equal to 1. So cosine squared theta is equal to 1 minus 1/9. But I'm going to change the 1 to 9 over 9. So cosine squared theta is equal to 9 9ths, take away 1 9, which is 8 9ths. And then I am going to square root it. And cosine in the third quadrant is going to be a negative, and it's root 8 over root 9. Break it up into two separate radicals. This is a negative 2 root 2 is simplified form of a negative, or square root 8, and that's going to be 3. And now that I know cosine, and I also know sine, look over there at the quotient identities. And do you notice that it says that the sine of theta over the cosine of theta is equal to tangent? And I already know that the sine, so I'm going to replace the sine of theta for what was given to me, that's a negative 1/3. I'm going to replace the cosine that's given to me, a negative 2 root 2 over 3. And this is equal to the tangent of theta. And that's what we're trying to find. Well, I'm going to take this, and I'm going to do a negative 1/3, and I'm going to flip it to 3 over 2 root 2, a negative. 2 negatives equal a positive, and the 3's cancel out. So you're left with a positive 1 over 2 root 2. But you can't leave a radical in the denominator, so you have to multiply the top and the bottom by root 2. So you're going to get a root 2 over a positive 4. And how I got a positive 4 is this makes 2, and 2 times 2 is 4. So I have to use two different formulas to come up with the answer. Okay, that's the 7.1 side, the front side. Let's do the back side. The next page, we're going to use formulas. We have the cosine of x over 1 minus sine squared x. And if you look at your formula sheet, you'll notice that sine squared x plus cosine squared x equals 1. So doesn't sine squared x minus 1 equal cosine squared x? So can I replace this with cosine squared x? And always work vertically. You have 1 cosine x on the top and 2 on the bottom, so you're going to have 1 over the cosine of x, because they both have a cosine of x, 1 on the top and 1 on the bottom, so you can take 1 out. And 1 over cosine of x is the same thing as secant of x. Final answer for number 1. Number 2. You have the cotangent of x times the sine of x. And on your formula sheet, you'll see that cotangent of x is equal to the cosine of x over the sine of x. I'm going to replace this with the cosine of x over the sine of x. There's a multiplication sign in between, so I'm going to write this as the sine of x over 1. And everything in the numerator can cancel out with anything in the denominator, so I can cancel out the sine, so you're left with just the cosine of x for number 2. Number 3, you have the sine squared x, and you have 1 plus the cotangent squared x. And on your formula sheet, under the Pythagorean, down in the lower left-hand corner, you'll see that the sine squared x and the 1 plus cotangent squared x, down at the lower left-hand corner, you'll see that 1 plus cotangent equals cosecant squared x. This is the same thing as sine squared x, and this is the same thing as 1 over sine squared x, because this is the reciprocal. You can put this over 1, and everything in the numerator is gained with everything in the denominator, so you're left with just a 1 for number 3. Number 4, you got sine of x times the cosine squared x minus sine of x. Okay, now you're going to use a little bit of algebra. If you have an x, y minus an x, you can take out the GCF, which is the x, and this is what you would have left over if you take the GCF out. Very similar here. This is broken up with a minus sign. They both have a sine of x in common. I can take it out. I'm going to be left with cosine squared x minus a 1, because sine of x goes into the sine of x minus 1. And you know that sine squared x plus cosine squared x is equal to 1. So sine squared x is equal to 1 minus cosine squared x. So I can come over here and replace this part with sine squared x. Almost sine squared x. There has to be a negative sign there, because do you see that this here is just the reverse of that? A positive cosine, a negative cosine, a negative 1, a positive 1. So you need to put a negative sign out in front, because watch, I can make this a negative sign. If I make that a negative sign, I make this a negative 1, and I make this a positive cosine. Now this looks like this. So the final answer is a negative sine cube x. That's number 4. Number 5, you have the tangent of x over the secant of x. Okay, now comes the rule of thumb for 5, 7, and 8. You want to change everything into sine and cosine. So tangent, there's a formula. Tangent is equal to sine over cosine, or tangent is equal to 1 over cotangent. But the rule of thumb is to change everything to sine and cosine. So I'm going to use this one instead. So I'm going to replace the tangent of x with sine of x over the cosine of x. Make a large line to stand for the division sign. Secant is 1 over the cosine of x. Change everything into sine and cosine. And then algebra, you're going to do the sine of x over the cosine of x. Change the division sign to a multiplication. Flip this to the cosine of x over 1. Anything in the numerator that looks like something in the denominator is game. I can cancel them out. So my final answer is the sine of x for number 5. And number 7, you've got the cosine of x plus the sine of x times the tangent of x. Okay, I'm going to leave the cosine of x because that's already in cosine or sine. I'm going to leave the sine of x, but I'm going to change the tangent to sine of x over the cosine of x. This is a pretty tough problem. This is leading into the next set of problems. I can't do anything with addition, so I can just copy it down and put the cosine of x and put a plus. I can't simplify anything, but I can multiply. This makes the sine squared x over the cosine of x. I can put the numerator together and I can put the denominator together. And I can put this over 1. But I'm adding two fractions together. In order to add two fractions together, you have to have a common denominator. So the common denominator is going to be the cosine of x. Well, this one's already got the cosine of x, so it's going to say sine squared x. This one needs the cosine of x, so I'm going to multiply the top by the cosine squared x, so we have cosine squared x. Now that I have a common denominator, I can do cosine squared x plus sine squared x all over one common denominator, which is cosine of x. In the lower left-hand corner of your formula sheet, cosine squared x plus sine squared x equals something, and this equals 1 over cosine of x, and that equals 1 over cosine of x is equal to secant of x. Final answer. And then the last problem for the day, number 8, you've got cosecant of x over secant of x. I'm going to change cosecant of x to 1 over the sine of x on your formula sheet, and the other one equals 1 over the cosine of x. I'm going to change the division sign to multiplication, so it's going to be 1 over the sine of x times the cosine of x over 1. There's nothing you can cancel out, so I'm just going to multiply this together, and I'm going to multiply this together, which makes cosine of x over the sine of x. And if you look at your formula sheet called the quotient identities, this is the same thing as cotangent of x. So these are all the problems worked out for you for 7.1. And I'll do that for 7.2 also.